Sometimes we are given quadratic equations that are not in the form of the vertex form. Instead, they're in the form ax squared plus bx plus c equals y. The majority of the work we did last year with quadratics were in that form. The problem with that form is that it's difficult to find some of the information we're often looking for. So we want to be able to change to vertex form. It's also much easier to graph them in vertex form. So to do that, we're going to do a process called completing the square. I'm going to give you a lot of steps, but I'm going to go through each one so you can see how it works. So if you want to take a minute to read through these steps, then I will walk you through each one as I go through example 1. So the first one says to divide to get rid of coefficients on the x squared. Since my x squared on example 1 doesn't have a coefficient other than 1, I can skip step 1. The next thing I have to do is get the x squared and the x, or the y squared and the y, on one side alone. So to get x squared alone, I'd have to subtract, and x alone, I'd have to subtract the 4. So I'm going to have x squared minus 6x equals y minus 4. Now I'm going to take my b term, which is essentially my linear term, and divide by 2. So negative 6 divided by 2 is negative 3. Step 4 says to square that, so I did 1 and 2, and there's 3. Step 4 says to square it, so when I square negative 3, I get a positive 9. Now I'll add that to both sides, giving me x squared minus 6x plus 9 equals y minus 4 plus 9. Okay, now I want to factor the side with the variable squared. So if I ask myself what two numbers multiply to be positive 9 and add to be negative 6, it's negative 3 and negative 3. Notice that I have a negative 3 right here. It is always going to work out that this number is going to reappear. So I will encourage you to do steps 3 and 4 individually, especially if you are dealing with a fraction and where it's difficult to determine what two numbers multiply to give you that fraction and add to give you another fraction. So I'm going to factor this to be x minus 3 times x minus 3, which is the same thing as x minus 3 squared. I can combine these and I get y plus 5. So I notice that this is in the form now x minus h squared equals 4p times y minus k. So looking back at my directions, I was supposed to then find the vertex and the p. Well, so then my vertex is going to be, x is going to be negative 3, y is going to be negative 5 because my formula is minus a minus. So if k was negative 5, I'd have minus minus equals plus. So I'm going to have 3, negative 5. So here's my y minus k. So I'm going to ask myself what p-value would have just a 1 out front. Because remember, if it's not written, it's a 1. So it looks to me that my p-value must be 1/4 since 4 times 1/4 is 1. Let's look at another example. There are 3 examples total. So example 2, I'm going to do the same thing. First thing I'm going to do is divide to get no coefficients on my squared term. Since x squared is not squared, I don't have to worry about that again. I can skip that. Then I'm going to collect both my x squared and my x term on the same side and move everything else over to the other side. So I'm going to add an 8x, and I'm going to subtract 36. Okay, oops, and I forgot my x. So now I'll take my linear term or my b term and divide it by 2, and then square that result. That number will get added to both sides, giving me x squared plus 8x plus 16 equals y minus 36 plus 16. I can now factor the left side, so two numbers that multiply to be 16 and add to be 8. 4 times 4 is 16, 4 plus 4 is 8. Again, it's coming from right here. So x plus 4 times x plus 4 is x plus 4 squared. These combine to be minus 20. So again, I'm in the form x minus h squared equals 4p times y minus k. So I'm asked to tell my vertex. Well, in order to get a plus 4, my x value of my vertex must be negative 4. My y value of my vertex is just 20. Again, I'm running into the same p situation as I did before, where I'm going to ask myself 4 times what value is going to make my p go away. Since I essentially have nothing written here, it would be a p-value of 1/4. Let's look at one final example. On this one, I'm going to have to do step 1 because I see that my squared term has a coefficient of 3. So there's 2 different ways you can do this. You can factor a 3 out, or you can divide everything by 3. I'm going to go ahead and divide everything by 3, especially since I can see that everything is divisible by 3, and in a later video, in our next section, I will show you how to factor out a 3 instead. So I'm going to divide everything by 3, and I'm going to be left with y squared plus 2y plus 5 equals 4x. And now, because the y is being squared, I want to get y squared and y together on the same side, so I'm going to subtract the 5. I'm going to take my linear term, my 2, and divide it by 2, and square that result, giving me y squared plus 2y equals, oh, and then I have to add that to both sides, so I forgot to add the 1, plus 1 equals 4x minus 5 plus 1. I can now factor the left, so I look for 2 things that multiply to be 1, add to be 2. Well, 1 times 1 is 1, 1 plus 1 is 2. Again, it comes from here. And I get y plus 1 times y plus 1, or y plus 1 squared, minus 4. So this one looks like it's in the form y minus k squared equals 4p times x minus h. Well, before I list my vertex and my p, I noticed that this form has x having a coefficient of 1. My form does not have x having a coefficient of 1. So whether this term is divisible by 4 or not, which in this case it is, but even if it wasn't, I would have to factor that out. So if I look at how that's going to be done, I'm going to have y plus 1, this side's fine, equals 4 times x minus 1. So now I can say that my vertex, my h value is always going to be with my x, so it's just 1. My k value would be negative 1. And my p value, in order to get a 4p to be 4, p must be 1. So that's going to be my steps for completing the square.